Good morning, good afternoon, good evening, everybody. My name is Tomas Gonzalez. I'm a Partner Solutions Architect at Sneak, and I'd like to welcome you to the developer experience on OpenShift. In this hands-on workshop, we are going to triage the vulnerabilities in an application deployed into OpenShift. These are vulnerabilities introduced by open source components, but also in the way that the workload is configured. So to get us started, I'm going to walk us over our demo environment and what we're going to be working in, just to give everybody a picture. So we have an application deployed into OpenShift. For this workshop, you are being provided access to an OpenShift environment where this application is already deployed. The application is exposed through a route, so you're able to play with it and interact with it. It is a very vulnerable and poorly configured application. And today we're going to be using Snyk to fix those vulnerabilities and those configuration issues. At the heart of this story is our Snyk OpenShift operator, which deploys our Snyk monitor into the cluster. And the Snyk monitor is what takes care of scanning the containers that are deployed in the pods, but also analyzing their configuration by parsing through the YAML file that dictates how that application is deployed into OpenShift. So for today, before we get started, I'd like to walk us over a few prerequisites. So let's go ahead and switch over to those. Okay, before we get started, there's a few things that we need to set up on your working environment so that you can complete the steps to this workshop. The steps to the prerequisites are available in the GitHub repository for this workshop in a file called prerequisite. There's a link below that you can pause the video and copy into your browser and open these up. So we're going to need 2 accounts in order to perform this workshop. First, you need a Snyk account. So go ahead and log in to app.snyk.io and sign in. It's free to create a Snyk account. And you're going to need an account for Quay.io. In this workshop, we're going to be building and pushing and then deploying a container image from Quay. So very important that you have a Quay.io login. Just sign in to Quay.io with your Red Hat login, and you should be good to go. Okay. Now, I'm going to be not showing the workshop guide during this workshop, so please open this up in your own computer. If you have a second screen, highly recommend using it so that you can have the workshop guide on one screen and you can have the actual workshop material in another. Now, let's get started and go through these prerequisites real quick. So for this workshop, you're going to need an IDE. In this case, I'm going to be using Visual Studio Code, but you're welcome to use any IDE that you want. You're going to need the Snyk CLI installed. So there's various ways to use the Snyk CLI. In the prerequisite documentation, there is a link to the installation documents for it. Verify that your installation of Snyk works by running the Snyk version command. You're also going to need a way to build containers. So we recommend using Docker for this workshop. If you'd like to use an open source alternative to Docker, you're more than welcome to. Just know that the instructions in the workshop are meant to be copy-paste friendly for Docker. But if you're familiar with alternative build tools, you're more than welcome to use them. Make sure that your installation of Docker works by also running the Docker version command, just to be safe. And then finally, for Quay.io, you'll need a repository since we're going to be building and pushing container images. So highly recommend creating a repository and calling it Goof. Goof is going to allow you to copy paste the instructions from the workshop guide. If you have a free Quay account, it'll need to be a public repository. In this case, we're just going to instantiate an empty repository. And one of the things that will be very helpful for copy pasting the commands, you can take your Quay username from the very top. Highly recommend in whatever environment you're going to be working on, set this as an environment variable. That way you can copy paste the commands. Now, before you log in, one last step that will help get us in the right direction is to log in to Quay.io and using that command. You can also copy paste this from the instructions, but what's going to happen is it'll ask you for your password. And once you've authenticated with Quay.io, you're going to be good to go. All right, with that, all the prerequisites are done and we're ready to get started with the workshop. Okay, now for the good stuff. Let's get started. The instructions for the workshop are available in the same GitHub repository as the prerequisites, just in the main README file. There's a URL below if you'd like to copy paste it, or if you'd like to just pause and insert this into your browser. And the workshop is broken up into two parts. In the first part, we're going to find the issues in the application that we've deployed into OpenShift. In the second part of the workshop, we're actually going to start fixing those issues. So I'm going to close the workshop guide. Again, feel free to have this open on your end. I'm going to be working directly in the products as we go. So before we get started, a couple things. You received an invitation to Snyk. There's a special organization in Snyk where we're going to be performing this workshop. Since our OpenShift operator and our Snyk monitor are functions of a paid Snyk plan, you will need to perform this workshop in this organization, unless you already have a paid Snyk account. But for this workshop, you have been invited in here. If you need assistance getting into Snyk, please let any of the workshop facilitators know. We'll be happy to help get you access. Now, you were also invited into an OpenShift cluster, and you were assigned a user. Please perform this workshop in the project assigned to your user. In this case, I am working on user 1. But feel free to pick from any of the other users that we have available. Now, in your project, just to walk you over what we have going on, we have the MongoDB, that is the backend for the Goof application, and then we have the actual Goof application. Goof is exposed using a route, so if you want to interact with Goof and play with it, it does work. And it may look harmless at first, but it's actually very vulnerable. And so what are we going to do? So one of the things as we said, we deployed the Snyk operator. It is deployed into the Snyk monitor project in OpenShift. This is a cluster scoped operator. And so what this is going to do is it's going to monitor every deployment config, replica set, daemon set, stateful set, cron job, pod in our cluster to identify the container that's deployed into that pod, and then also look at the configuration elements of that deployment to see if it's really configured to best practices. And so hopping right back to my user 1 project, this is exactly where we're going to start. So we're going to start by logging into Snyk. Again, make sure you are in the special organization that we have designated for this workshop. The very first thing we need to do is import this workload into Snyk to see what it looks like from a security and configuration perspective. To do that, navigate to the Projects tab in Snyk. It'll currently be empty, but as people start importing workloads, it'll slowly populate. Head to the Add Project button, select the Kubernetes icon, and find the cluster that we have configured. You might see multiple clusters because we have run multiple instances of this workshop. If you're not sure which one to select, look at the URL of the OpenShift cluster that you're currently logged into and find that one here. Now, find your designated project. So if you're user 1, like I am, work in user 1. If you're user 50, look for user 50. And select the Goof application to import into Snyk for monitoring. You can also import the MongoDB. It's not what we're going to be interacting with during this workshop, but definitely if you want to see an example of how a container image that is a dependency of an application that wasn't necessarily built internally might still have security and configuration risks. So while this imports, a couple of things are happening. So our operator is reaching out to the deployment spec, finding out what container is deployed in that pod. It's pulling it into the temporary storage that is claimed by our operator, and then it's scanning it. So we're not actually executing the container. We're pulling the image from the registry and scanning it as it's meant to be deployed. And then once it's done, you're going to see here under the deployment app goof, which is our application, 2 different lines. Line number 1 is the workload line. So if you click on this line, it'll take us to a summary of the workload, both from a security and configuration perspective. If you go to the container, then you'll see just the security issues with that specific container image. So right now, let's first start looking at the workload summary to get an idea of the types of things that we'll be fixing during this workshop. Really quickly, we can see a couple things. Number one, we're not setting CPU and memory limits. Good news is we're not running as root. We're also not running in privileged context. But we are not running a read-only file system, and we are not dropping capabilities. So our container right now has more access or more privileges than it should. We're going to be fixing those later. Another thing that you can see here, these in the bottom are the issues with the container image from an open source security perspective. So this is the related container project that we were seeing in the under section of the workload summary. But for what we see for each vulnerability is we see the component that introduced the vulnerability. We can see if there's a fix available for this vulnerability. These are all references to external sources to read information about this vulnerability. So if you want to read about this CWE, you can definitely head over to the Common Weakness Enumeration website, learn about it. You can see information about the CVE. And you can also see information from the Snyk database. This is the research performed by our security team where we are aggregating all these external sources and more, plus performing our own proprietary research to figure out really what is the impact of this vulnerability. Now, other bits of information that are in here, you get to see where it came from. In the case of workloads that have multiple container images, you might see multiple containers associated with this workload. This is where it ties us back to what container actually introduced this vulnerability. You can see the same view if we return to the Projects tab and you expand the workload summary and you go straight into the goof. Now, there's a slightly different thing about this view that I want to call out. Number one is you still see the same issues, but what's different is now you can actually also generate the full dependency tree. So if you want to see all the dependencies, all the open source components that you're deploying into this container, which means you're deploying them into this workload, you can get a view of that here. You can also see specifically what transitive dependencies each of those components introduced. And if you want to filter this view to just vulnerable dependencies, you're totally able to do that. That gives you an idea of where the vulnerabilities that are in your container are actually coming from. Now, to give us a head start remediating the vulnerabilities, you also might have noticed that Snyk is suggesting base images. So one of the things that our operator does is it looks at the signatures of all the layers of the container that you're deploying to try to infer what base image are you using to build this container. That's the from statement in your Docker file. So in this case, we're using node 10.4.1. And what Snyk is doing in an attempt to accelerate remediation, it's going to propose alternative base images that we can use in our container to potentially give us a head start with hundreds less vulnerabilities. For example, node 10.4.1 Jesse has 962 vulnerabilities. But we see here that if we packaged our application into node 17, which of course is a major version upgrade, so that's something for an architect of the application to consider. If it works and it is a worthwhile upgrade, you can drastically reduce that to just 38 vulnerabilities just from picking a more secure base image. So with that, just to recap what we saw before going into part 2 of the workshop and fixing it, you have an application deployed into OpenShift. Our Snyk Kubernetes operator, as well as the Snyk monitor, are deployed into that same OpenShift cluster as cluster scoped. You imported the workload into Snyk to see the security and the configuration issues. Then you got an idea of what configuration issues are the ones that we should be looking at. You also saw the open source vulnerabilities and potentially what base image you can rebuild your container on top of to drastically reduce the number of vulnerabilities in that image. Now, in part 2 of the workshop, we're going to take this information and apply it with the information that Snyk gives us locally when running the Sneak CLI in the command line to see how we can fix these issues and make the workload most secure. So with that, let's get started with part 2. So for part 2, one of the prerequisites was to install the Sneak CLI. The next thing we have to do to be able to use the Sneak CLI is we have to authenticate it. So to create a service account token that you can use to authenticate the CLI, head over to the gear in the upper right corner and find service accounts on the left. And we recommend creating a service account with your user number. That way we can tell it apart from all the other ones and to help us troubleshoot in case something happens. So in this case, since I'm user 1, I'll create a service account called user 1. And it will only show the token once. So copy that token and then head over to your IDE. In this case, I'm using VS Code. And similarly to what we did with the Quay user, recommend saving that as an environment variable just in case. And then once you have that saved, you can authenticate the Snyk command, the Snyk CLI, using that token. Snyk is now ready to be used. Perfect. So first step to start fixing the configuration and security issues in our application is we have to clone the repository. So in the workshop guide, you have the URL of the goof rhpds GitHub repository. This is the GitHub repository for the application that we deployed into OpenShift. And so you need to clone that first. In my case, I've already cloned the application and I've changed into the directory for the application. Now, to see how we could take the security information before we deploy the application into OpenShift, we're going to start by building the container image that is currently in our OpenShift cluster, but locally. So what we can do that using the docker build command. So docker build tag, and since we're going to be uploading it into Quay, we want to make sure that this is why it's important to have the Quay user saved as an environment variable. You can copy paste this command from the workshop guide, but go ahead and call it goof, just like the repository that you created in Quay.io. And since this is before we make any fixes, let's go ahead and tag it before. This will also give us the ability to compare it to the deployment after we make the fix. So with that, let's go ahead and build. Oops, I forgot the period. Now, the build might take a little time, so take this moment if you need to stand up, stretch a little bit, get a glass of water, or if you have any questions, feel free to write them in the chat. We're more than happy to assist. But a couple things that are going to be happening here in the background is Docker's going to reach out, pull the base image, follow the instructions in our Docker file, package all that neatly into a container. But we're not actually going to be deploying this container image. What we're going to be doing with this image is scanning it so that we can see the same vulnerability information and the same base image remediation guidance that we saw in the Snyk user interface, just in the developer's workstation, to get an idea of how this could work and how you could use Snyk before pushing an image to a container registry. Let's give this a few minutes to finish. And while this runs, again, if anybody has any questions, feel free to reach out in the chat. Any of the moderators here facilitating this workshop will be happy to assist. Beautiful. Once the image finishes building, your computer might have finished way before mine. You might have gone ahead in the workshop guide. But what we're going to do next is list out the images. Make sure we can see the image that we just built. Beautiful. At the very top. Fantastic. Now, next step is to scan the image for vulnerabilities using Snyk. I've copy-pasted the command from the workshop guide. A couple things are happening here. So after you invoke the Sneak CLI, you then tell it what type of test you want to do. In this case, this is a container test. If you wanted to do an infrastructure as code scan like we'll do later, you'll see that the command is IAC. If it's an open source test, you just do plain Snyk test. If it's a static analysis test of the code, you do Snyk code test. But what we do is we pass the name of the container image that we want to scan. And then optionally, we can provide a path to the Docker file. And what that does is it allows us to see what base image you used by reading the from statement of the Docker file. But it also allows us to see if you have any other instructions in the Docker file, such as run, add, or copy statements that might have also introduced components. And we differentiate those both in the Snyk UI and in the output of the Snyk CLI by vulnerabilities that were introduced as part of your base image or vulnerabilities that were introduced as part of your user instructions. Now, we have to wait a few minutes for the container scan to complete. So while it completes, if anybody has any questions about the workings of the Snyk CLI or how it is that we're doing this analysis, please let us know. We're here to help. Again, if your computer has finished before mine has, feel free to continue with the workshop or wait along with the group. Fun fact while we wait, if you already use Docker to build and manage your container images in your registry, this exact same scanning experience is natively built into the Docker tools. Give the Docker scan command a try. Under the covers, it's running Snyk container test under the covers. First part of the scan is done. So the first part is all about collecting the list of dependencies in the image. The second part of the scan, which is what gives us the output, is about matching those against our vulnerability database. So in the list of vulnerabilities, we can see the same information we saw in the Snyk UI that was picked up by our Kubernetes integration. You can see here's, for example, a high severity vulnerability. The type of vulnerability is a link to the Snyk knowledge base around the vulnerability, where it was introduced. So this was introduced by our base image. And what version of node was this fixed in? So you can see that on a per vulnerability basis. You can also see the same base image upgrade guidance that you saw in the Snyk UI. So you can see these are grouped by how likely they are to be compatible with your current image. So a minor upgrade, as the name implies, is just a minor version upgrade. So from 14.1 to 14.18. A major upgrade is a major node upgrade, so from 14 to 16. And then alternative base image types are slimmer images that have less packages. So they're significantly smaller. Because they have less packages, there's a very high chance that they have less vulnerabilities. So what we're going to do is we're going to take this base image recommendation and rebuild our container using the base image upgrade guidance provided by Snyk. In this case, we're going to do the minor version upgrade to node 14.18. So to apply this, I'm just going to go into my Docker file. And what we'll do is we'll comment out the old base image and add in a new from statement for the new one. So now we're going to build this image off node 14.18. And let's go ahead and build it. So let's find the Docker build command that we ran earlier. And instead of tagging it before, let's tag it after. And to symbolize that we have the image before the more secure base image and the image after the more secure base image. This allows us to look at the results side by side and compare. It also allows us to test the new base image without necessarily replacing the other one that might be running in production. So this allows us to build it locally. We're going to be able to test it and repeat this process until we're satisfied with our selection of base image. So for now, while this runs, we'll let it run again. And if anybody has any questions about the results that we got from Snyk, the base image upgrade guidance, or how we applied this base image in the Docker file, please let us know. We're here to help. Now, if you're a developer building containers, you might be hesitant to blindly trust the advice that Snyk is giving around base image upgrade guidance, and you'd be right to do so. Base image upgrade guidance is meant to be a suggestion, an indication of potentially a less vulnerable starting point for your container image, but it is by no means something that should be trusted blindly. It does not replace the need for proper unit, functional, and integration testing. So the idea, if you have a continuous delivery workflow, you would create this container with a different base image, test it locally. If you're satisfied, then deploy it maybe to a different project or a different namespace in OpenShift and test it to make sure the application performs as expected. And once everything looks good, merge this change into your main production branch so that you can replace the image that's running in our cluster. So in this case, we're taking a few shortcuts. We're building the image locally. We're going to then push it to Cli, and we're going to straight up replace the deployment in OpenShift. But it is, again, not a replacement for proper unit integration and functional testing. So just because we're not doing that today doesn't mean you should not do that. Beautiful. Once the image finishes building, let's go ahead and push it into Quay so that we can deploy it into our OpenShift cluster. While this works, you might have noticed during the build log that npm audit ran as part of the npm install process. This is a mechanic that npm uses to identify open source components with vulnerable dependencies in the application. Now, application dependencies are out of scope for this presentation, but while we wait for the image to push to Quay, the Snyk Vulnerability Scanner plugin for VS Code can find those same vulnerabilities that npm audit finds and more, and as well as provide information about the remediation, if there's an exploit available for that vulnerability, is it trending on social media. So feel free to play with the Snyk Vulnerability Scanner plugin while you wait for the image to push to Quay. I wanted to address that since it did come up during the container build logs that npm audit ran. So feel free to play with that while we wait. If you have any questions, feel free to shoot them in the chat. We're here to help. Beautiful. Once the image has been pushed, we can go into Quay and refresh just to make sure that our image successfully uploaded. So here it is, our after tag of the image. Now, the next step is to redeploy our application into OpenShift. We're going to do this from the OpenShift developer experience. So log back into the OpenShift user interface, head over to the topology on the left. If you're not already in the developer experience, shift from the administrator experience to the developer experience. Select the deployment of Goof. Then in the actions in the upper right corner, head over to edit deployment. And what we can do in here is we can replace the image that is currently used for this deployment. So go ahead and replace that with your Quay address. And save. So what you should see OpenShift do now is it'll tear down the old container after spinning up the new one. Beautiful. Once our application's running again, we can hit the URL again just to see if it's working. It is. Okay, again. Now, in the background, Snyk has started, it recognized that a new container image was deployed for this deployment, and it's going to start rescanning it. And once it gets rescanned, then it'll show in the project screen, in the Snyk user interface, under the project that you previously imported. Though you can accelerate this process by re-adding it. So go to Add Project, to the Kubernetes integration, find the cluster that we're using, and import the user one deployment app Goof. Might have done that a little too fast. I'll do it one more time. What's a demo if something doesn't work exactly as expected the first time, right? Let's refresh. And so what we can see here, here's the old image that we were using. Sneak Labs Goof is the one that's deployed by default. And then here's our new safer image with many less critical and high severity vulnerabilities than our old one. If we go into this project, we'll see the exact same information we saw before. Again, every vulnerability with a priority score, exploit maturity, remediation information, and more base image upgrade guidance in case we decide to try to further reduce the number of vulnerabilities by upgrading the base image. So that's it for how Sneak Container can help us select a more secure base image for our container. Now, there are still outstanding vulnerabilities in this container image. The idea is now you have a much smaller pool of individual components to upgrade by bumping those dependency versions in your image. So instead of having to deal with 80 components that introduce high critical severity vulnerabilities, you now only have 9, which makes it significantly easier to triage the vulnerabilities in your image. Though we've only fixed one aspect of it, that we have not yet fixed the configuration elements in our deployment. So in this next section, what we're going to do is we're going to use Sneak infrastructure as code to find the issues with our deployment manifest, and then see how we can start fixing those using the OpenShift developer experience. So in this case, all the manifests that deploy our application are available in the manifest folder. And to scan those with Sneak, you simply use the Sneak infrastructure as code test command and point it at the manifest folder. Since this one's just looking at the contents of this YAML file, we can see here, here's everything that we can do to improve the configuration state of this YAML. We're not running with CPU limits. We're not running with memory limits. So we're starting to see exactly the same information that we were seeing in the Sneak user interface. The difference is that when using the Sneak CLI, it tells us where you can apply the change in order for this not to be an issue anymore. So after reviewing these scan results, you would ideally update the YAML file here and add the limits under the requests. But in this case, since we're not actually committing these changes to source control, we can do that within the OpenShift developer experience once again. So head to the Goof deployment, go to the actions, back to edit deployment. And this time we're going to use the YAML view. And this is the exact same YAML that was used to deploy the application, except in the OpenShiftified, or OpenShift added a few other bits of metadata to the deployment, things like that. So if we wanted to fix the issue with our limits, for example, and get those checks in Sneak showing green, we could come in here and add those. No more than 250 on the CPU, and no more than 250 on the memory. Save. Once we do that, this was a fairly passive change, so it didn't really require redeploying the application. If we go back into Sneak and we go back into our projects view and add the project once again to force it to refresh, it will eventually refresh automatically, but we're doing this, to force it to refresh. Then once we go into the user1 deployment apps.goof, we now have a pass on the CPU and memory limits. So we have secured at least one element of the configuration. And that's about it. If you'd like to continue fixing the other two elements, go ahead and run the Sneak infrastructure as code test command again, or find here where you have to make the change that would turn that light to a green, and go ahead and keep playing with it. At this point, this workshop has concluded, and so we are here to help. Feel free to keep playing with it, keep playing with Sneak. This OpenShift workshop environment is going to stay running at least for 4 more hours. So if you'd like to try deploying your own applications or try different workloads, you can use this Sneak environment and this cluster as your playground. But for now, you've reached the end of this workshop. Thank you for joining me. for for walking through how Snyk container and Snyk infrastructure as code can help you secure two elements of your OpenShift workloads. There are a couple things that we did not cover that are definitely worth checking out about Snyk. We already talked about open source application security issues, but we also have code security and quality issues that we can find, like SQL injections, cross-site scripting. While those are out of scope for this workshop, if you're interested, please reach out. And the Snyk team or the Red Hat team or the IBM team, can get a demo environment set up so that you can start playing with everything that Snyk has to offer. Thank you for joining me today, and enjoy the rest of the conference.